we now have the ability to get the distance from our ultrasonic sensor in our MR1 robot, and we can also make the wheels move. So in theory, with that knowledge, we should be able to start making the robot do something by itself, move around, for example, in a maze and not be able to figure out how to get around it, but actually not run into the walls. That would be a good start. So basically we've got our ability to do that, but before we do that, we need to actually start thinking about some important programming concepts. And the first programming concept I want to get across to you is the idea of a function, sometimes also called a sub-program or a sub-routine. A function is just a block of code. So it's a block of code, and here you can see in the example, the flowchart I've got that appeared on the screen just now is our ultrasonic sensor flowchart. So it preps the sensor, it sends a pulse, it measures the echo, and it calculates the distance. And every time we need to measure our distance, we need to do those 4 steps. So a function is just a block of code with the exception that you give it a name. So we name the block of code. So it's now called getDistance, and all we've done is added some extra lines of code in around that to call it getDistance. So we've given that block of code a name. The advantage of that is that you can call the function over and over again without having to write it out. So for the example on the far right hand side, I've now got turn the robot left, get the distance, turn the robot right, get the distance, and then do whatever. So for example, you're making the robot check to see if there are any cars coming before it crosses the road. So basically, we have the ability to call that function over and over again. Functions are more powerful than that still, because there are some extra features of functions which enable us to do far more powerful things. But we're starting at the basics, so we're just going to worry about the idea that we can call our functions, and we're going to do that by creating some motor functions. And you'll see that in the code that we're just about to look at, I've already created the getDistance function, so we can see what that looks like before we start. So here we are in our code for our robot, and it looks pretty similar to what we already had. And as you scroll down, you'll notice that the first change that I've got is a bit further down, a bit further. There it is, the loop. This is the loop that actually runs the robot. And in this loop, I've got this getDistance here, and I'm actually calling the function. And that's how you call a function in the Arduino programming language, is to say getDistance, open and close brackets, and then finish that function off. And all the loop is doing is it's getting the distance, it's waiting for 1/4 of a second, and then it's going to get the distance again, and it's going to wait for 1/4 of a second. You'll notice down here that all of the code that I've already written, all I did is copy it and pasted it, and I put it inside the function. And this is how you name a function. You say void getDistance, open and close bracket, and then you open this curly bracket or brace, and then you close it down here. So it's opened and closed. And see, if I highlight that one there, you can see that the other one is sort of boxed around, so you can see which one opens which is sort of important. And all of that code is what I'd already had, but I used to have it in a loop. So it's going to call this function. Now if you're really observant, I've actually got 2 extra lines here. I've got digital write on the light high and digital write on the white light as low down the bottom. And that's just to make the light flash on and off while it is trying to read the distance. And that's just to give you an idea of how long it actually takes to read the distance. So I'm going to run that program for you now. I'll show you what it looks like on the robot, and then we'll actually make some observations about that. So you would have noticed that, yeah, you can still hear the clicking noise, but the clicking noise isn't like a buzz, it's just a quick click, click, click every 250 milliseconds. And you also may have noticed that as the phone or the video camera got closer to the distance sensor, this bit of the algorithm here, this bit of the program took less time to happen. So that's actually, the light didn't flash for as long. But there you go, it's basically calling this every 2 seconds. So you could literally make the robot turn left with the motor, send out a pulse to get the distance, then look right and send out the pulse, and then look backwards, forwards, and decide whether it should cross the road, for example. And that's basically how a function should work. So you should probably make your code have a get distance function, and test your get distance function the way I have, before moving on to creating the motor functions, which we'll do now. Writing the motor functions is pretty straightforward. We'll just go right down the bottom, and I normally like to keep my motors in my functions in alphabetical order. So the first one I'm going to do is to move forward, and move LMG HIJKLM. So move forward comes after, actually type in void first, and we type in move forward comes after get distance. And oops, now just in here, basically what we're going to do to make our robot move forward is not move, we're going to go digital, analog right. Getting a bit confused this morning. Analog right, and we're going to write the right motor forward, so RMF, and let's just move it forward at a constant speed of 200. I'd suggest you never go full speed with your robot, because then you've got no area to correct, and I'll explain that one later. And right, analog right, left motor forward, and we'll move that forward 200 as well. And then we need to have a way of stopping our robot, so void stop all motors. That's nice and descriptive, that tells you what you're going to do. And we're going to press enter in here, and we'll type in, actually we'll copy and paste this, Control C or Command C if you're on a Mac, which I am, Command V, and we're going to change that to 0 and 0. Let's go up to the main loop now and call these functions. So we've got the get distance function, we've got a delay of 250. Then we say move forward, and then we'll have a delay of, let's just say 2 seconds. And then we'll say stop all motors, and we'll stop the motors, and then we'll have a delay of 1 second, and let's see, hopefully I haven't got any errors. I've got my robot plugged in. My robot's plugged in. I'm going to load it up into the script and check the errors. I'm not going to video it just yet, because I know for a fact that my motors are turned off. So let's turn my motors on, and there's a little switch on the motor controller which I can press and turn on and off. There it is there, and you can hear it going. Let's get the video camera going now. So you can see there it flashes, motor moves forward, it stops, and that's quite nice. So basically we've got our functions going. Let's continue with this. Let's create a turn left and a turn right. Now, turn left and turn right will come after, and turn left will come first. So let's do a void turn left. And like I said, I keep my functions in alphabetical order. It makes them easier to find later. So to turn left, what I need to do is I need to say analog, and I'm creating for myself a problem here. So to turn left, I actually need to move my right motor forward and my left motor back. So let's just go right motor forward, and I'll move my right motor forward to let's make the turning a bit slower. So we'll go 150, and we'll say analog right, and we'll go left motor reversed 150. Okay, so hopefully that will be good, and then we're going to say void turn right, open and close, and we'll copy the same thing, Command C, down here Command V. Let's just make sure that that's all good, and whoops, a bit further, but this will be right motor reverse, and this will be left motor forward, which will turn us right. Now let's put this into our script now. Stop all motors, and I'm going to create a problem for myself here. So I'm stopping all motors, then I'm going to actually make this really short too, because I don't want my robot to run off the cliff. So I'll make it 500 milliseconds, and then I'm going to make the robot turn left, and I'm going to put the delay in of I'll put a delay in of 1 second, so let's see how far it turns in 1 second, and I'm going to put turn right, and this is where you'll see the problem, and I'll see if you can guess why, of that far, and let's just delay it by 1 second, and we'll see how we go of running that. So I'll run this while it's on the stand, and we'll see if we can spot the problem. I'll actually run it while it's on the stand, and it hasn't got the motors running because I turned them off. So it's forward, turning one way. Oh, what happened there? Oh, it's gone a bit haywire now. It's just not quite working properly. The motors aren't working all over the place. And the problem here is we need to remember that this is a difference motor controller. And what's happening is when we're changing down here, this one here to this one here, these are still set. So we actually need to turn or stop all motors before we issue any commands. So in each one, we actually need to call the function stop all motors in there. Let's copy that. And we don't need to call it in itself, but if you call a function inside itself, you get an error, by the way. And Command V. So if we actually upload that, I know what the problem is. Silly me. Stop all motors needs to actually have, where is the stop all motors? There it is there. Command C, Command V, and that needs to be RMR and LMR. Okay, let's run it now. Once again, turn the motors on. That seems to be working. Let's see what it looks like if I actually unplug him from the computer and put him down on the ground. And the ground's a bit slippery here, so basically he's not getting a lot of grip, but that's basically what we need to be able to do in terms of functions and having functions working. So basically, hopefully I'll be able to edit this video nicely so that I don't have all those errors in it, but basically we need to be able to write functions in order to create our robot smoothly, and it's very obvious to me what this robot's doing by reading the loop. If I actually had all of that code also in there, it would be very difficult for me to understand what the robot's doing. But now I can see very simply that I'm getting the distance, I'm moving forward, I'm stopping all motors, I'm turning left, I'm turning right, and then I'm basically doing that over and over again.